Introduction. Coordinated motion control in independent dual pneumatic IDP systems could synchronize multiple pneumatic actuators using PLCs, sensors and feedback mechanism. Despite challenges, advancement in control algorithm enhance manufacturing efficiency, making it pivotal in modern industrial automation.
Hello, my name is Sharmila. My message number is KN210014. Today I will present about the project overview. In this project, we need to make a program using the programmer and the Steam Kinematic to control two-axis robot with AP1. We also choose 5.1 problem statement for our project. We learned something new in this project, how to identify the problem in our project.
They have three objectives in our projects. First objective is to design the programmer and identify the problem for two-axis robot engineering projects. Second one, to develop in utilizing CS programmer software to address engineering challenges, testing and resolving PLC programming error are all part of this process. And for the last one, is to demonstrate the capacity to put theoretical understanding of PLCs and pneumatic to use in order to solve problems both individually and as a team of our leader. Goal in our project is design and implement a robust motion control system for two-axis station robot using the IDP system, and utilizing CS programmer and FluidSim software to address engineering challenges, test and resolve PLC programming errors.
Next, I will explain about the design statement. The two-axis Cartesian robot is started when the PB start push button is pressed. The arm will move downward and the down sensor will be active. Gripper will grip the load for 3 seconds and will move upward. After that, the up sensor will active and move to the right. Sensor right will active, then move down. After 3 seconds, the load has been ungripped and the arm will return to its initial position for 5 seconds. The process will be repeated 3 times before stopping.
And for the input and output, we use start button, reset button, right sensor, up sensor, down sensor, and left sensor, and middle sensor. And for the output, we have grip, up down arm, left arm, and right arm.
I will explain about the motion diagram. First, when we press the start button, the up down arm will move down. After that, down sensor will active. After the down sensor active, grip will on, and the timer 000 will active for 3 seconds. After that, up down arm will move up, and up sensor will active. After up sensor active, the right arm will move to the right and the right sensor will active. After that, right sensor active, the up down arm will move down and the down sensor will active. The timer 001 will active for 3 seconds. After timer active for 3 seconds, ungrip will on and the up down arm will move up and up sensor will active. After up sensor active, Timer 002 will on for 5 seconds. Left arm will move to the left and the counter 000 will count for 3 times. After timer count 3 times, the counter will reset. Lastly, when we press the stop button, the system will reset all.
Displacement step diagram for our project is we have three. For the first, we have down and up. For the second one is grip and grip, and last one is right and left. Displacement step diagram we follow by motion diagram and problem statement in our projects.
Okay, now I will present for the explanation for the round 0 and also round 1. Okay, for round 0, when the PB1, which is 0.05, is pressed, it will energize the keep IR1, 110.00. The keep will allow the circuit to remain energized even after the start button is released. The parallel normally open contact of IR1 ensures that the circuit remain latched on until the stop button, which is 0.006 is pressed, which will open the stop contact and de-energize IR1. Okay, for round 1, this round is for the left arm operation. For the first branch, which is the left arm, 100.02 will operate when the C000 contact and up sensor 0.03 is activated. And also the T002, which is time, having time out. For the second branch, the left arm will operate when the IR1 and up sensor is activated without the grip 100.00 and also after T002 having timeout. When the left arm reaches the left sensor, it will stop operating. For the third branch, the left arm, which is 100.02, will operate when IR2, which is 110.02, and up sensor is activated. Okay, next is the explanation for round 2 and round 3. For round 2, this round is for the operation of the up and down arm. The up and down will operate when the IR1 on 10.00 and right sensor 0.01 and also grip 100.00 is activated without the IR2 110 and 0.02 activate. The next up and down arm operation will operate when the IR1 110.00 and the left sensor, which is 0.00, is activated, and also when the T000 is having timeout without the IR2 operate. The IR2 will cut down the operation if it's activated. For round 3, this round is for the arm grip operation. So when the IR1 110 left sensor 0.00 and also down sensor 0.04 is activated, it will energize the set operation 100.00, which is the grip. Next is the explanation for the round 4 and round 5. Okay, first thing for round 4, this round is for the right arm operation and the timer for gripping boss A. Okay, when the IR1 110.00 and grip 100.00 is activated, it will energize the timer T000 and it will start the count for 3 seconds. The right arm 100.03 will also operate when the IR1 110.00 and grip 100.00 and also the up sensor, which is 0.03, is activated. Okay, for round 5, this round is for the timer for ungripping the arm at box C operation. When the right sensor 0.01, grip 100.00 and down sensor 0.04 is activated, the timer T001 will be energized and will start the count for 3 seconds. Okay, next I will explain for the round 6 and round 7. For round 6, this round is for the ungripping operation for the first branch when the contact C00 is activated. It will energize the grid, which is 100.00, which is the reset instruction for it to ungrid. For the second branch, when the T001 is having timeout, it will energize the grid 100.00, reset instruction for it to ungrid. For the third branch, when the IR2, which is 110.02, it will energize the grid, which is 100.00, reset instruction for it to ungrid. Okay, for round 7, this round is for the counter operation, for it to look for 3 times. Um, when the T001 is activated, it will energize the counter instruction and the count on the counter will drop by 1. For the second branch, the stop button, which is 0.06, will energize the counter if it's activated and will stop the counter instruction, and also reset the counter count to its initial number, which is 3. Okay, lastly, for the explanation for the CS programmer. Now it's the explanation for the rank 8 and also rank 9. Okay, for rank 8, this rank is for the timer when reaching the up sensor. So when the up sensor, which is 0.0 T3 is activated, the timer T002 will energize and will start the count for 5 seconds. For rank 9, this rank is for the stop button operation, which is to move the arm to its initial operation, to its initial position. When the stop push button 0.06 is pressed, it will energize the IR2, which is 110.02, and then will energize the timer T003 and will start the count for 3 seconds.
And so for the method explanation, when we press a push button, up down cylinder will extend and it will trigger negative BG2. After it's trigger negative BG2, grip and ungrip cylinder will extend, and also TO will energize, T0 will energize for 3 seconds. After 3 seconds, up down cylinder will retract and activate negative BG1. Negative BG1 will trigger the negative BG3 and also trigger negative MB3. When it trigger negative MB3, the left right cylinder will extend and trigger negative BG4. At the same time, the cylinder up down will extend. It also will trigger timer 1 for 3 seconds. And after 3 seconds, the ungrip and up down cylinder will retract at the same time. After it's retract at the same time, negative T2, negative timer 2 will also energize. And after it energizes, it after it energizes for 5 seconds, it will trigger the counter for 10 cycle.
So next, I will explain about the experimental set of this level. And you can see in this picture, we have 2-axis Cartesian robot and PLC. We connect PLC with 2-axis Cartesian robot. We connect input and output. And for 0 volt, we connect to the COM. For 24 volt, we connect to the positive. In this picture, you can see the PLC. First, we have the power, and we have input and output. And for PLC, we use PLC 1E and 20.
1, 2, 3. Problem and failure in CS programmer. The problem is after we press the PB stop, the up down arm will stop and doesn't move to initial position. So the solution is we add relay to IR2 for each round to cut off after the stop button press. For the second one is after we press the PB start, we should press again the PB start. Then our solution is we add keep instruction in round 0. The operation can run do not to press the PB start for 2 times.
Okay, next I will explain about the problem that we face for hardware. The problem that we face is the 2-axis Cartesian robot will not operate. The solution that we do is we open the lock of Cartesian robot, then the robot can operate immediately.
For FluidSim problem that we have to face, when the timer T1 is active, the timer T0 is also active. So to make sure the problem is solved, we add a contact relay negative KF5 added to the Node 6 adding circuit.
Discussion. What can we discuss from this project? The project optimizes industry automation with a 2-axis robot and CP1E PLC for coordinate motion control. Challenges in CL programmer are addressed through meticulous code review and collaboration. In FluidSim simulation, continuous validation and collaboration fine-tune the model. Transitioning to hardware involves rigorous testing, calibration, and understanding CP1E, PLC, and robot hardware for seamless implementation.
Last but not least, in our conclusion is the project aims to optimize industrial automation with 2-axis robot using CP1E PLC for coordinated motion control. Challenges in CS programmer and FluidSim simulation are addressed collaboratively for precise logic sequence. Transition to hardware require rigorous testing, calibration, and close integration for reliable motion control. The project underscores a commitment to enhance efficiency and precision in industrial automation through seamless CP1E PLC and 2-axis robot integration.